Hello friends, I Professor Darshan Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for the subject head Control System Engineering. So friends, as far as our today's session is concerned, so we will try to learn how to determine the overall transfer function of this signal flow graph representation by using Mason's gain formula. As we know, the signal flow graph technique, it was invented by this American scientist whose name is nothing but Samuel Mason. So on behalf of his invention, the name given to that formula is nothing but what? Mason's gain formula. So by using this Mason's gain formula, we are supposed to determine the overall transfer function of that system, and in this way this Mason's gain formula is to be written, that is nothing but 1 over delta summation of pi into delta I, right? So this is all about this Mason's gain formula. So we do have a certain parameters of this Mason's gain formula. Parameter in the sense, the most important parameter of this Mason's gain formula is nothing but what? The system determinant that can be qualities as a delta. So first of all we need to understand how this delta is to be tabulated. So before going for this delta, this is how our signal flow graph will look like. Then after that, what we need to do, first of all we need to determine the system determinant whose name is nothing but what? Delta. So let us quickly go through this delta. Delta equals to 1 minus of, within that first parenthesis we used to have this term along with the subscript operator P11, P21, P31, n number of term we do can have. Then after that second parenthesis we used to have P12, P22 and P32. Similarly within that third parenthesis we used to have P13, P23 and P33. So one question arises in our mind, what this term stands for. So one by one, according to this first, second and third parenthesis, we need to understand. So first parenthesis is nothing but what? We do can call it as a, this is the addition of individual loop gain. So first of all we need to determine from sake of observation ki how many number of individual loops we used to have within the signal flow graph representation, and their gains are being added within that first parenthesis. So this P11 is nothing but the first individual loop gain, P21 is nothing but what? The second individual loop gain, P31 is nothing but what? The third individual loop gain. Like this we used to have the n number of loops, and means we need to add the n number of individual loop gains. So this is all about this first parenthesis, right? Now as far as the second parenthesis is concerned, so once we had tabulated ki how many number of individual loops we are having, then as far as the second parenthesis is concerned, so this P12 is nothing but what? It is the gain product of first two non-touching loop, right? P22 is nothing but what? The gain product of second two non-touching loop. Means within that second parenthesis we are supposed to add the gain product of two different non-touching loops which are present within this signal flow graph representation. Like if suppose we are having the first two non-touching loops, so their gains are being multiplied, which is denoted by this P12. Apart from these first two non-touching loops, if suppose we are having another identical non-touching loops, so the second two non-touching loops, their gains are being multiplied with this statement P22 like this, right? Third parenthesis stands for what? The P13 means it is nothing but what? The gain product of first three non-touching loop, the gain product of second three non-touching loop. Likewise, within that first parenthesis we are having the individual loop gain. Within that second parenthesis we used to have the gain product of first two non-touching loop, second two non-touching loop. Within that third parenthesis we used to have, very rarely this term is being used because that third term stands for what? The gain product of first three non-touching loops, second three non-touching loops up to n number of three non-touching loops, right? So before tabulating this system determinant, right, as I told you earlier, this is nothing but what? The Mason's gain formula that can be rewritten in this way also. This transfer function equals to summation of pi into delta I upon delta. Now the question arises what this pi and delta I stands for, right? So pi is nothing but what? Ith number of forward path we need to determine, and later I will tell you the meaning belongs to this term that can be qualities as a delta I, right? So first of all we will try to determine this fellow whose name is nothing but what? P suffix I. So P suffix I is nothing but what? The ith number of forward paths we need to determine. Now one question arises in our mind, what do you mean by this forward path? So the simple answer for this question is nothing but what? Forward path is nothing but the way in which we can complete our journey from R to C, right? That is nothing but what? The forward path. So first of all, we need to determine how many number of forward paths we are having with us. So for sake of moment, I will rub all these things. Once we know clearly, the resistance gain formula is nothing but what? Here I will write. Transfer function equals to summation of Pi into delta I upon delta. So for ith number of time, the summation sign will get iterated, means number of iterations equals to number of forward paths, right? So first of all, we need to determine the number of forward paths within that first step. So see, this will be the first straightforward forward path, which consists of that much portion of this signal flow graph, right? Means we can start our journey from this R and we can end our journey at this C. So the first forward path will be what? Here I will draw the portion of that first forward path. This is how it will look like. Here the gain in between these two nodes is nothing but what? 1. Here the gain is what? How much it is? G2. Here gain is G4. Here gain is G6, and this is nothing but what? 1. So its overall gain equals to what? As these elements are connected in series form, so their gains are being multiplied. So as a result of this, it will become G2 into G4 into G6. Right? That will be the first forward path. Similarly, the second forward path, the lower portion, right? This will be the second forward path. See, here the gain is 1. Again here it is G3. Here it is G5. Right? G5, it is G7 and 1. So it will become G3 into G5 into G7. Similarly, we can have the n number of forward paths. So the third path will be what? When we start our journey from this R, so we will go through this G2. Then after that we'll go through this G1, from this G1 to G7, and we can end our journey at this C. So how that path will look like, here I will draw. This will be G2, this will be G1, and this is G7, and this is nothing but what? C. So this is R, C. Here gain is 1. Here the gain of this path is G2. Here the gain of this path is G1. Then again it is G7 and 1. So P3 equals to G2 G1 into G7. Similarly, the forward path number 4, instead of going through this G2 G1 G7, which was already mapped in case of that previous path, now we need to follow the lower path. When we start our journey at this R, so we'll go through this G3. Then after this G8, G6, and we can end our journey at this 6 at this C. So how it will look like? I will draw here. This will be G3. This will be G8, G6, and C. See, the gain of this path is 1. Here the gain of this path is G3. Then this is G8. This is G6, and the gain of this path is 1. So as a result of this, it will become G3 into G6 into G8, right? So far we have tabulated the 4 forward paths. As we can see, along with this forward path, 2 feedback elements we used to have with us, along with this negative sign denoted by this H suffix 1 and H suffix 2. So with the help of this feedback element also we can complete our journey from R to C. So how it is, let us quickly go through. How that forward path will look like. See, we will start our journey with this R. We'll go through this G2, right? Then apart from this, along with this G2, yes, we'll go through this gain. we'll go through this forward path whose gain is nothing but what, this G suffix 1. Then with the help of this feedback element, we'll come across this particular node. Then again with the help of this G8, G6, and we can complete our journey at this C. So for more clarity, I will draw here. See, that journey is being started from this R. The gain of this path is nothing but what, 1. So here it is G2. Then as I told you earlier, this is the diagonal element whose gain is nothing but what, G1. Here we used to have the feedback element whose gain is exactly equals to minus of H2. Then again with this another diagonal element will come across at that particular node whose gain is nothing but what, G8, and with the help of this G6, and this is nothing but what, C, and the gain of this path is nothing but what, 1. So here the overall gain will become what, here I will write, right, this overall gain of this forward path, which consists of 1, 2, 3, 4, 5 and 6 forward path and 1 feedback path whose gain is nothing but what, minus of H2. So its overall gain will become I will write that gain in terms of this ascending order. So along with this negative sign, it will become minus of G1 into GT into G2 into G6 times of G8, right? Similarly, the forward path number 6 or the last path, now instead of going to this upper part of the signal flow graph, we can complete our journey from R to C with the help of this part. How it will look like, I will draw here. This will be R. Again the gain of this forward path is 1. Then instead of going to this G2, I will go through this G3. Here the gain of this forward path is how much? Here G3. Then again with the help of this diagonal element, here I will draw. This is the diagonal element whose gain is nothing but what? G8. Then again feedback element we used to have whose gain is nothing but what? Minus of H1. Here we are coming across this node. Then again with the help of this diagonal element whose gain is exactly equals to how much here? Whose gain is exactly equals to G suffix 1. I will come across to this particular node. Then again with the help of this G7, I can complete my journey at this C. So as you can see, it consists of 1, 2, 3, 4, 5 and 6 forward path and 1 feedback element. So its overall gain will become 1. Again I will write in this ascending order along with this negative sign. So minus of G1 into G suffix 3 into G7 times of G8 followed by H1. As far as this previous forward path is concerned, so I had forget to write this feedback element whose gain is nothing but what? H suffix 2, right? So these are the 6 forward paths we are having with us. Apart from this 6 forward path, we don't have any forward path through which we can complete our journey this R and we can conclude our journey at C. So in this way, we need to determine how many number of forward paths we are having with us. Once that forward paths are being tabulated, then the step number 2, what we need to do in that step number 2, this is all which we had done so far belongs to step number 1, in which we have tabulated how many number of forward paths we are having. In that step number 2, we need to determine how many individual loops we are having with us, right? So loop means what? We can say that from control system engineering point of view, we can say that it is the circulating path, right? This is the basic definition of that loop. Once we had started our journey at that particular node, so we the time when we are concluding our journey at that same node, so that entire portion which belongs to in between these two nodes, that can be called it as a loop. So first of all, we need to determine how many number of loops we are having with us. Okay friends, so welcome back. In that next step, we need to determine how many number of loops we are having with us. So first of all, we need to observe how many number of feedback elements we are having with us. So there are two feedback elements, H1 and H2. So at least there are two loops, right? Apart from these two loops, again one more loop we are having in the signal flow graph representation. So first of all, we need to enlist. So here I will draw due to this lack of space. This will be the first loop belongs to this H1. So how it will look like? This is how this first loop is being represented. This is the feedback element H1 whose forward path is nothing but what? The gain of that forward path is G4 in between these two nodes. And according to this system determinant P11, that will be what? The first individual loop gain. So here P11 equals to what? P11 equals to the multiplication in between these two parameters. So it will become minus G4 times of H1 will be the first individual loop. Similarly, we need to define the second individual loop, the lower part, right? Associated with this H2 whose forward path is nothing but what? Here I will write G5. So the first parenthesis is concerned P21 equals to what? Minus G5 into H2, right? Now one more loop we are having with us. So how it will look like? Here I will draw the third loop. This is how we need to consider these two diagonal elements. These are the two feedback elements, minus of H1, and this is nothing but what? Minus of H2, and the diagonal elements are nothing but what? This is G8, and this is nothing but what? G suffix 1. So here overall gain will become what? That can be called it as a P31. So P31 equals to this minus minus will become plus, as we are having two feedback elements. So G1 into G8 followed by H1 into H2, right? So this will be the third loop gain. Now it's time to write the statement for this delta. Delta equals to what? It is 1 minus of P11 plus P21 plus P31. So P11 is minus of G4 times of H1. So it will become 1 plus G4 times of H1 plus P21, second individual loop gain. Again it is minus G5 times of H2. So it will become plus G5 times of H2 minus this third individual loop gain G1 G8 into H1 H2. Right. This is how the first parenthesis is complete. Plus. Now what we need to do? We need to define the first two non-touching loops. Right. Now non-touching loop means what? They are not sharing the similar element or they are not sharing the similar nodes. Right. So from sake of observation, we are coming on to this conclusion. Clearly these two loops are non-touching loops. The reason number one is what? They are not sharing the similar element. The reason number two is nothing but what? As well as they are not sharing the similar nodes. It has nothing to do with us, right? Loop number one and loop number two. So their gain product itself is a parameter which is to be written within this second parenthesis P12, right? So P12 equals to what? P11 into P21, right? So P11 equals to what? Minus G4 times of H1, and P22 equals to what? Minus G5 times of H2, right? So their product will become what? Their product will become G4 into G5 times of H1 into H2, right? So as far as this delta is concerned, so plus this term is to be written G4 into G5 followed by H1 into H2. So this entire term that can be called as a delta, right? Now as far as the third parenthesis is concerned, so we don't have this third parenthesis, right? Third parenthesis is what? The gain product of first three non-touching loops, second three non-touching loop and third three non-touching loops. We are having only three loops. Out of that three loops, first two are the non-touching loops, right? So we don't have such type of configuration key which will tell us key we are having first three non-touching or second three non-touching loops, right? Now the remaining thing is what here, in order to complete this Mason's gain formula, this parameter is remaining, delta I. So delta I will be iterated for how many number of times? This delta I will be iterated for ith number of time. Ith number of time means what? That summation sign is being iterated for ith number of times equals to number of forward paths. So as we are having 6 different forward paths, P1, P2, P3 up to P6, right? So whenever we are determining this delta I, right? So delta I is nothing but what? 1 minus summation of all loop gain, which will not touches to ith number of forward path. Means for sake of our convenience, when we are going to determine this delta 1, delta 2, delta 3, delta 4, delta 5 and delta 6, right? So at that time delta 1 equals to what? Delta 1 equals to 1 minus summation of all loop gain, which will not touches to the first forward path. So we need to determine such type of special portion in the signal flow graph which will not touches to the first forward path. The gain of that first forward path is what here? G2, G4, G6. So we need to determine which portion is isolated from this G2, G4 and G6. Which portion, in the sense we need to find out the desired loop, right? Which will not touches to this first forward path. So this lower loop has nothing to do with this forward path, right? So delta 1 equals to 1 minus summation of all loop gain, which will not touches to that first forward path. So there are 3 loops. Out of that 3 loop, this loop will not touches to that first forward path. So delta 1 will become what? 1 minus the gain of this loop. The gain of this loop is nothing but what? Minus it will become plus. So G5 times of H2. This will be delta 1. Similarly, delta 2. Delta 2 is nothing but what? The special part of that graph which will not touches to the forward path number 2, because the gain of that forward path number 2 is nothing but what? G3, G5 and G7. This G3, G5 and G7. This lower part, right? So clearly we can say that this loop has nothing to do with this forward path number 2, means this loop will not touches to this forward path. So as a result of this, delta 2 equals to what? 1 minus actually, but minus it will become plus. So 1 plus H1 times of G4, right? So we are having only 2 deltas, delta 1 and delta 2. As far as delta 3, delta 4, delta 5 and delta 6 are concerned, all these parameters are concerned. So we don't have any loop, or we don't have the special part which will not touches to forward path number 3, forward path number 4, forward path number 5 and forward path number 6. As a result of this, delta 3 equals to what? It is 1 minus 0, delta 4 equals to 1 minus 0, delta 5 equals to 1 minus 0 and delta 6 equals to 1 minus 0, right? So finally, our transfer function will become what here? As I told you earlier, it is to be decided with the help of this Mason's gain formula, right? So for how many number of times the summation sign will get iterated? For 6 times, because we are having 6 different forward paths. So transfer function equals to what? Here I will write transfer function equals to the gain of that first forward path G2, G4, G6. Here I will write G2, G4, G6 plus gain of that second forward path G3, G5 into G7 plus gain of the third forward path G3, G6, G8 plus gain of that fourth forward path number 4, whose gain is nothing but what? G3, G6, G8. One more gain is remaining, G2, G1, G7, G2, G1, G7 plus. This is the statement for forward path number 5 and forward path number 6, right? So along with this negative sign, it will become, now see, apart from this forward path, the statement is what? The statement will be like this. Just a minute. Transfer function, here I will write, transfer function equals to P1 into delta 1 plus P2 into delta 2 plus P3 plus P4 plus P5 plus P6 upon delta, right? Now as far as this delta is concerned, so already it is being tabulated, which is being written within this rectangular box. Now as far as this numerator is concerned, so within that numerator we need to write P1 is nothing but what? The gain of that first forward path, G2, G4, G6, right? It will get multiplied with this delta 1, already it is being tabulated, 1 plus G5 into H2. Delta 1 means what? The 1 minus summation of loop gain which will not touch to that first forward path. So as a result of this, in this way we need to write. So here I will write, now due to lack of space, what I will do, I will remove this one and here I will write so transfer function equals to, here I will write transfer function equals to P1 into delta 1, right? P1 equals to what? G2 G4 into G6, G2 G4 into G6, right? Will get multiplied with this delta 1. Delta 1 equals to what? 1 plus G5 into H2, 1 plus G5 into H2 plus P2 is nothing but what? The gain of second forward path, G3 G5 into G7, G3 G5 into G7 into delta 2, the 1 minus summation of loop which will not touch to forward path number 2, which exactly equals to, already it is being tabulated, 1 plus H1 times of G4, 1 plus H1 times of G4 plus, right? Now delta 3, delta 4, delta 5 and delta 6, all these deltas equals to 1, right? So instead of writing delta 3, delta 4 and delta 5, delta 6 plus, what we need to do, we need to add the loop gain of the desired gain of loop number 3, gain of loop number 4, loop number 5 and loop number 6, means we need to add P3, P4, P5 and P6. So already it is being written, right? So this will be P3. So here I will write plus G2 into G1 into G7, P4 equals to what? G3 G6 into G8, G3 G6 into G8 plus, right? P5, right? P5 is denoted with this negative sign, so it will become, here I will write, so it will become minus G1 G2 G6 G8 times of H2, right? Similarly, that will be the forward path number 6 denoted with this negative sign, so it will become minus G1 G3 G7 G8 times of H1, right? This whole term divided by, its denominator is nothing but what? Delta, so already it is being tabulated. It is 1 plus summation of all individual loop gain minus, it is that can be called, it is as the gain product of first two non-touching loop, second two non-touching loop. So accordingly, its denominator will become 1 plus, here I will write G4 times of H1 plus G5 times of H2 minus G1 G8 times of H1 H2. Actually these three are nothing but what? The three individual loop gain, first, second and third, right? The last term is nothing but what? G4 G5 H1 H2, G4 G5 H1 H2. What it is? This is the gain product of these two loops, that can be called, it is as a first two non-touching loop. So this entire term will be the transfer function of the signal flow graph representation, right? So far what we need to do, Mason's gain formula, it will look like this, right? Which exactly equals to 1 over delta into summation of pi into delta I. So first of all we need to determine how many number of forward paths we are having with us, denoted by p suffix I. Once these forward paths are being declared, after that we need to determine how many number of individual loops we are having with us. Out of that individual loop, we need to determine whether we are having first two, second two, third two non-touching loops, or first three, second three, or n number of three non-touching loops. Then we need to include all these things within that formula along with delta I. So delta I is nothing but what? That can be called, it is as the 1 minus summation of all loop gain which will not touches to that ith number of forward path. Means whenever we are considering the delta 1 belongs to forward path number 1, which will tell us Delta 1 is nothing but what? 1 minus summation of all loop gain which will not touches to forward path number 1. So in this way all these parameters have to be tabulated, and finally this is how this transfer function is to be determined. So I just hope you had understand all these things belongs to this Mason's gain formula used in case of the signal flow graph representation technique.